Hey everybody, this is Larry. This is April 27th of the Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem. Power of 3. So yeah, so I have a new mic today. Let me know how the sound goes. Yeah. I don't know, that's pretty much it. Just join me on Discord or give me a feedback somewhere. And then for this problem, the question is, power of 3. So I usually solve these live, so it's a bit slow, fast forward. I think this one seems pretty straightforward. Given an integer of n, return true is a power of 3, otherwise return false. Okay. Okay, so can you solve without loops or recursion? So the answer is so there are two things, right? Well, there are a couple of things. But well, one is that negative numbers are never powers of 3, just to be clear. So we can skip that and we just focus on the positive numbers. And in theory, they're only like, what, 20 power of 3s or something like that? I don't know the math. You could do the math, right? Log base 3 of 2 to the 31st, which I'm just guessing is like about 20. I don't know. But so you have 20 numbers and you can put them in a set and then do a lookup in all of one time, quote unquote, right? Of course, that doesn't scale with respect to the size of the universe, but you can do it. And the loop recursion method is very simple. You just basically keep on dividing it by 3 and checking that it is, that you can divide it by 3, right? Can you do it without loops on recursion? Well, I mean, I kind of gave one way of doing it without it. I mean, you could even just do it manually, right? Because you have like, what, 1, 3, 9, 27, 81, and then you go, and then dot, 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 right? Maybe I can't do it manually, but you get the idea. Is there a clever way? Well, I mean, I know that in certain libraries that would be fun because then you convert it to a base 3 number, and if it's a power of 3, then it is in a base 3. It's just 1 followed by a lot of the zeros, right? So yeah, I actually don't know how. Does Python have a library? Convert to base. I don't think so though, because I feel like if I did, or if it did, then yeah, because I remember I think you can only there is a function to convert a string to assuming that is a certain base, but not the other way. Maybe I'm wrong on that one, but I know that in Java you can. So then that would be pretty straightforward. But I mean that's also kind of cheating because then you can they implement it in some way. It's just that you didn't implement it, right? How do you do without loops or recursion then, without the hard-coded way? I don't know that I know this one. Maybe it's some like weird trick, like this one trick will get you a job at enter your favorite company. But yeah, I don't know. Dun dun dun. Trying to think if there's a clever way. But this seems like a simple problem for the most part, other than the follow-up. I only mentioned 2 ways, even though they're both half cheating. I don't know if there's anything cleverer than stuff like that. Like I know that in like in binary, there are a couple of funky things you can take advantage of bitwise operations, but I don't know that you can do it with ternary numbers, or at least, I mean, maybe you can, but then like I feel like that kind of, or like essentially that's what I would be doing with a for loop, right? Except for that, maybe there's some like bitwise logic that lets you do it, check in a quicker way, but that seems just a little bit overkill. So I'm just going to do it with a for loop or whatever, just do it with recursion maybe. But yeah, I'll do it with recursion because I haven't done that in a while. We've done force, if n is equal to 1, return true. Otherwise, return self dot is power of 3, n of 3. If n mod 3 is equal to 0, otherwise return false. I think this is right? Roughly speaking. I guess I could just put 09.5, 81, I don't know. And then just maybe say like 18. Because it's just 2 times 9 or something, right? Alright, so is this good? This looks good, so let's give it a submit. I mean, I should check negative numbers, but I guess I just returned false. So let's give it a submit. Cool. Yeah. Now I'm curious whether you can do the follow-up, so I'm going to, look that up. I mean, this was pretty trivial, in general, because it's not a... yeah, if you're a little bit rusty on the math, that's another story. But yeah, this loop, base conversion. Okay. Actually, I mentioned this. I just said that I said that yeah, that's what I was thinking of. That's why I was saying that in Java there's a way to do it, because I used to use this for some reason. Well, not this reason, but for other reasons. So that's good. So I was kind of right. I just didn't do it, but I don't know if there's a Python way of doing it. Mathematics. Oh, I guess so. I actually should have thought about this one maybe, but it's also a little bit awkward because even though this doesn't have for loops, this is very prone to precision errors. Maybe not very prone to precision errors, but at least non-trivially prone to precision errors. And it's kind of what I said about ternary numbers, except for, I don't know. I usually, for discrete problems, I don't think about floats. Maybe I should from time to time, because I think, so I mean, it's just that, if you're familiar with, it's just that there are a lot of nuances with error tracking and like error margins and stuff like that makes it a little bit yucky. But like mathematically this makes sense. It's just that for me, I'll be very sketched out about like, there may be some way. Yeah. Oh yeah. They actually even mentioned stuff like this where yeah, you have to use an epsilon or something, but even this epsilon, it's like I think a lot of people get used to just putting a like 1 g -6 or something like that. It's an epsilon to play around, but that like if you're really diligent, you're supposed to proof your epsilon a little bit, but that's another story. That's why I don't use it. Integer limitations. That's what I said too. So I said this solution too. I just thought, and my guess was 20, but apparently this is 3 to the 19. So I was close off my head. I didn't even think about this one. But this is kind of cute actually. No, I did not mention this. I actually mentioned putting everything in a hash table, but they actually did this a little bit clever as well, where they take 3 to the 19th mod and okay, I buy that. And then now there's just some performance thing. I don't know. It's fine. And as I was, and if you're gonna do that, you only have 20 numbers anyway to look up in a hash table, though. And in theory, you could just put it all in memory, so it's not even, like you don't. It's 19 elements. It's not gonna. You don't even need a set. You could just put in an array because there's an array of 20 elements, and then you just go through it really quickly or something. And everything's in memory, right? And probably even in good cache. But yeah, that's all I have really. Don't really have anything else. I mean, all the complexity I mentioned here, it killed my. I guess I didn't go over my complexity, but this is a pretty grade school type problem, which is not to say it's easy per se, because this is just stuff that a lot of people haven't touched in a decade or something, right? So you may have struggled a little bit with it, but yeah. But the idea is that this will run in log n base 3 times, meaning that, if it's 3 to the 10, it'll take 10 loops or recursive steps or whatever, right? So yeah, so that's gonna be all of that. And in terms of space, technically actually it's more efficient if you do a while loop, because then there's no stack space. Right now I do use stack space, so it's also all of log n base 3. But you just do a while loop like you should, or you could, you do it in all of one time, or sorry, all of one space. But I, to be honest, I usually do it. I usually do these things with while loops because it's more straightforward. But I don't know. I think today I just wanted to mess around and have a little fun. But yeah, that's all I have. We went over all the other solutions very briefly. Let me know what you think. Let me know which one you did, and I will see you tomorrow. So yeah, be good, do well, do good, and good mental health. I'll see you later. Bye bye.